In this lecture, we will study about the chapter Amines. We know the structure of ammonia. It is NH3. Formula of ammonia is NH3. If hydrogen of ammonia is replaced by either alkyl group or aryl group, the corresponding product so obtained is either RNH2, that is alkyl amine, and ARNH2, aryl amine. These compounds are of important class of organic chemistry. Let us consider how they are important. Naturally occurring compound proteins, vitamins or alkaloids, they contain amino compounds or say amines. Novocaine, which is one of the important drugs that is utilized for dentistry as an anesthetic form, is also amine compound. Benadryl, which is one of the important antihistamine, is also one of the important amine compound, artificial amine compound. Polymers, dyestuffs, polymers say or dyestuffs say, they are also amine compounds, as well as quaternary salt are used as surfactants. That is why this chapter we need to understand. Now first of all we will study the structure of alkyl amine or aryl amine. In amines, N is sp3 hybridized. Hybridization of nitrogen in amines is sp3 hybridization. So bond angle is found to be 109 degree 28 minutes. But if alkyl group, say methyl group, everywhere methyl group is attached, this is nitrogen, sp3 hybridized, here it is electron pair, non-bonding electron pair, and if all the three groups attached here are methyl group, then bond angle is 108 degree, not 109 28 minutes, but it is found to be 108 degree. Now we will study classification of these amine compounds. Primary amine compound or say primary amine, RNH2, means only one hydrogen of ammonia, only one hydrogen of ammonia is replaced by either alkyl group or aryl group, CH3NH2 or aniline, aminobenzene, primary amine. R2NH is secondary amine. R2NH is secondary amine. Example, we can take CH3NH, CH3. This is secondary amine. And one more possibility is R3N, that is 3 degree amine or tertiary amine. Now, the same is possible for aryl compounds also, that is aryl amines. This is 1 degree amine, aromatic amine. But if we write NCH3 twice, then this is said to be 3rd degree amine or tertiary amine. And if we write NHCH3, then it is said to be 2 degree amine. But these three are cases of aromatic amines. Now we will study heterocyclic compound, heterocyclic amines. We have few examples They are nothing but heterocyclic amines. One is pyrrole and second one is pyridine. In pyrrole and pyridine, N is present but they are of heterocyclic. Now we will study IUPAC nomenclature of these compounds. First compound CH3CH2NH2. Because of two carbon present with amino group, it is said to be ethanamine. IUPAC name is ethanamine. For second, CH3NH CH3CH3. So IUPAC name is N-dimethyl. N-dimethyl. Anywhere we have CH3 group. So N-dimethyl. Now one carbon remains. That is why methanamine. N-dimethyl methanamine. Now third one. One side we have CH3 group. Another side we have CH2CH3 group. So first of all we will take CH3 with N. So N-methyl and methyl. Total number of carbons remains 2. That is why ethanamine. N-methyl methanamine. Now fourth one. This is known as aniline. Now fifth one, NH2 on carbon number 1 and total number of carbon atoms are 3. That is why total number of carbons 3, but on the second group we have ethene alkene group. That is why total 3. That is why pro 2 in. Pro 2 in. But on one number carbon we have amine group. That is why pro 2 in 1 amine. Pro 2 in 1 amine. Now aniline but with CH3. So first of all we will consider NH2 as 2-amino toluene. IUPAC name of this compound will be 2-amino toluene. Observant. We have CH3 2 times. So N-dimethyl aniline or benzamine also we can speak. N-dimethyl aniline. So this way we can give IUPAC name to different amine compounds. Now we will study methods of preparation of amine. First method, reduction of nitro compounds. Reduction of compounds with NO2 group. Take example of nitrobenzene. Nitrobenzene on reduction with SnHCl or FeHCl, the product so obtained is aniline. But if we utilize iron scrap and hydrochloric acid, it is advantageable because FeCl2 produced on hydrolysis gives HCl, and that is why we can start the reaction with small amount of HCl. That is why iron scrap and HCl is easy to utilize. Second method, reduction of nitriles. Reduction of nitriles. RCN, that is the general structure of nitrile, in presence of LiAlH4 or reducing agent NiH2, RCH2NH2, that is amine, can be prepared. Take example CH3 CH2Cn in presence of reducing agent, the products to obtain is CH3, CH2, CH2, NH2. Third, by reduction of amide group. Or compounds containing CONH2 group. RCONH2, again in presence of reducing agent, the products to obtain is RCH2NH2. Amine product is produced. Now we study one important method to produce 1 degree amine is Gabrielle Elamite synthesis. What is Gabrielle Elamite synthesis? Elamite, structure of Elamite is this one. This is Elamite. When Elamite is treated with KOH, first we get the product NK, COONK. When this product is treated with alkyl halide RX, next step we get this product having alkyl group, and on reaction with HCl we get, that is with, not with HCl but with NaOH, we get COONA plus RNH2, that is 1 degree amine, or say primary amine. So once more we revise Gabrielle Elamite synthesis. In Gabrielle Elamite synthesis, Elamite reacts with KOH. The product obtained so is treated with alkyl halide. Alkyl halide and this sodium salt of Elamite gives us this product having R group, that is alkyl group, and on treatment with NaOH it gives us primary amine. But this method is unable to produce aryl amine. Means aryl amines cannot be produced by Gabrielle Elamite synthesis. Now we will discuss one more method, that is Hofmann bromamide method. Fifth method, Hofmann bromamide method. RCONH2 amide compound on treatment with Br2 and aqueous NaOH or alcoholic KOH gives us RNH2, that is amine, plus Na2CO3, NaBr and water. So Hofmann bromamide method, amide gives us amine, means we get 1 carbon less than the original or say parent reactant. RCONH2. We here get RNH2. The reagent utilized are bromine and aqueous or alcoholic NaOH. Now to balance this, there is one trick to remember. We can remember it by this way: 114 on reactant side and 1122 on product side. Once more, 114 on reactant side. So writing this coefficient, we will get 1, 1 and 4. And here we can write 1, 1, 2, 2. So 1, that is RNH2 amine, 1 mole. 1 mole of Na2CO3, 2 moles of NaBr and 2 moles of H2O. So this is one way to remember it in easy manner. 114, 1122. 114, 1122. We can take example of CH3CONH2. CH3CONH2 plus Br2 plus 4NaOH will give CH3NH2 amine with 1 carbon less than the parent reactant plus Na2CO3 plus 2 sodium bromide plus 2 moles of water. If we have aryl amide plus bromine plus 4NaOH will also give aniline plus Na2CO3 plus 2 NaBr plus 2H. In Hofmann bromamide, R group or say methyl group or simply say alkyl group or aryl group migrates towards nitrogen. So how this is possible? If we understand the mechanism, then we will understand migration of AR or R group towards nitrogen. R CO NH2 OH minus will react with any of these hydrogen, produces RCONH. Now Br2 will be in the form of Br. This electron will be shifted here, so it will be Br minus and this will be Br plus. So it will attack here. We will get RCO N Br and H. Again attack of OH minus on this hydrogen. We get RCO N Br. Now alkyl shift takes place and this is slow step. So also it is rate determining step. And finally we are getting Rn double bond C double bond O. So here we can understand that alkyl group or aryl group which was with carbon has been shifted now towards nitrogen. Now method 6 of preparing amines. This method is known as Hofmann's ammonolysis method. In this method, primary, secondary 3-degree amines as well as quaternary salt are formed between the reaction NH3 and alkyl halide. NH3 plus alkyl halide, say methyl iodide, reacts and gives NHCH3 NH2 methyl amine Again CH3I gives CH3NHCH3. Again on reaction with CH3I, CH3NCH3CH3. And in final reaction with methyl iodide, we get CH4CH3 4 times, CH3 and this CH3 4 times, and I. So this is known as quaternary iodide salt. This is quaternary iodide salt. Now we can see in this method we obtain primary amine, secondary amine, and 3-degree amine. So we get mixture of complex compounds, so it is difficult to separate them. But if we take ammonia in more proportion in the beginning, then only primary amines are obtained. If ammonia is taken in large proportion in the beginning, then only 1-degree amines can be prepared. Now we will study the mechanism of Hofmann's ammonolysis method. This mechanism is a typical case of nucleophilic substitution reaction. Once more, it is necessary to remember Hofmann's ammonolysis method is a typical case of nucleophilic substitution reaction. How it behaves like nucleophilic substitution reaction, so we will understand by understanding the mechanism. Ammonia, which has a lone pair of electron, reacts with Rx, that is alkyl halide. On reaction, it gives RNH3X. Ammonia plus Rx gives RNH3X. This is said to be 1-degree amine salt. Now RNH3X with Rx molecule with ammonia molecule, RNH3X with ammonia molecule produces RNH2, 1-degree amine, and NH4X is liberated. So in the next step, RNH2 reacts with Rx to give R2NH2X. This is 2-degree amine salt. This 2-degree amine salt again with ammonia, NH3, 2-degree amine salt or secondary amine salt with ammonia gives R2NH, NH4X again liberated. Now in the next step, R2NH plus 1 more mole of Rx, that is alkyl halide, gives R3NHX. 3-degree or tertiary amine salt. 3-degree amine salt. Reaction with ammonia gives R3N plus again NH4X. And in the final step, R3N plus Rx alkyl halide gives R4NX. R4NX. This is known as quaternary salt. This way, we are getting mixtures of amine and it is difficult to separate them. Now we will study one more method of preparing amines, that is method number 7. The name of the method is Schmitt Method, in which acids are converted to amines. Method number 7. Schmitt method. RCOH means acid. On reaction with hydrazoic acid in presence of concentrated H2SO4 gives RNH2. RCOH acid, when reacts with N3H hydrazoic acid in presence of concentrated H2SO4 gives amine compound. Primary amine. And beside with that we can say nitrogen gas is also liberated. Now next method, that method number 8, is known as Curtius degradation method. Curtius degradation method. In Curtius degradation method also, acids are converted to amines, but the method is different than Schmitt method. RCOOH, that is acid, reacts first with thionyl chloride to produce acid chloride, RCOCl. When RCOCl is react with NaN3, sodium azide, the product so obtained is azide product. Product so obtained is azide product. On heating, it gives RNC double bond O. So if we compare this method, Curtius degradation method, with Hoffman bromamide method, in Hoffman bromamide method also, alkyl group or aryl group was shifting from carbon to nitrogen. Here also, R group is shifting from carbon to nitrogen. And finally, on reaction with NaOH, we get the product RNH2, that is amine. So these were some methods to obtain amines.